It's my privilege to introduce our next speaker, Dr. S.Sreekanth sir, who is the assistant professor in Koti Women's College and has 20 years of teaching experience, and he has great contribution to research in the field of computer-aided drug design and its methodologies, molecular modeling, synthetic organic chemistry, computational and molecular docking studies of metal complexes, and DNA binding studies, and has published 79 research papers with 700 citation and having 17 H index in reputed international and national journals, to say Nature, scientific reports, and so on, and has given 6 invited talk in the reputed conferences and workshops, and has patent grant on thiourea derivatives of oxandrol as potential anti-cancer agents, and has also working as assistant coordinator in IQAC. And with all this, we are glad to introduce our next speaker, who is going to present on AI-assisted ADMET tools. Kindly carry on. Thank you.
Good evening all. Thanks for the small introduction. And anyway, it's not just AI ADMET tools I'm talking about. I'll just go through briefly about one or more tool that you can use for ligand-based virtual screening, right? I'll start with that, then we'll go into what are the tools you can use for structure-based virtual screenings. Just show you where you can find them, and then we'll go into this ADMET tool kind of thing, right? So as I was browsing through articles kind of thing, I happened to see one of, in 2024, I guess, an article published in JCIM, Journal of Chemical Information Modeling, where they have mentioned this PYRMD, right? It's a new fully automated AI-powered ligand-based virtual screening tool. Now you have already created one. You have seen how the script is generated in Python, and you can run different algorithms. Like you have used RF now, right? But you can change the codes, right? Using different algorithms, you can put them. You can use multiple algorithms, right? For who are good with ChatGPT, you can just go on to ChatGPT, get the codes. But integration of these codes into the PY file is a bit tricky kind of thing, right? The ChatGPT will give you the codes, but where to put, how to put, that's what you need to learn, right? So once you have these codes, you can see how to interlink them, right, and get the virtual screening run up for you, right? That's one way of doing it. Now this tool, they have not gone for ANN or your decision tree or kind of thing, right? They have gone for a new set of algorithm as such. This is the article that I was saying about, right? Right. So this, you can see, it is an interface that is using a different. You can use million of compounds to screen from this, right? You have an algorithm specific for ligand-based virtual screening. This is right, and you can directly take the data that you can obtain from Campbell database. No need of any curation of the data. Excel sheets, converting them, removing of the non-values, you don't have any standard values, nothing. You can directly give the Campbell database here. The CSV file directly, n number of molecules, thousands, lakhs molecules you can give in that single Excel file. It will curate by itself. That's the advantage of this particular one, right? And it's kind of a structure similarity search, which is based upon the fingerprints, right? Molecular fingerprints. You can have 1064, 20, 48 fingerprint modules kind of thing to be used here, right? And the algorithm that it uses is this. I'm not a mathematician, so I cannot explain you what this matrix or algorithm means about. They have used this random matrix discriminant algorithm. It's actually a variant of random matrix analysis, right? That's normally used kind of thing. So they have changed it to a random matrix discriminant analysis. The one thing that they have added in this thing is when you take the database, right, you have to specify what are the active molecules, what are the inactive molecules. You classify them, active and inactive, keeping a threshold value, right? Now, normal algorithms, what we see is we take the fingerprint values of those active molecules, generate a model based on the actives, and then screen out if inactives are coming into the active group or not, right? That's how the models are in general written, kind of thing, right? But this particular algorithm also considers inactives, right? The descriptors, basically what it calculates is the eigenvalues and the eigenvectors, right? So to start with, it takes both active and inactive eigenvalues and eigenvectors and classifies the molecules based upon that. So if in a matrix, if any molecule is out of a particular matrix, it is taken as a new point or new value for it, and it is used. So it gives a better classification as well as better description about a particular molecule. So they have developed this, right? So input data is about molecular fingerprints. There you have dividing into active and inactive. There's two modes of functioning of it. One is called as a benchmark mode. Other one is called as a screening mode. Two modes are there for this software, right? Benchmark mode is nothing but you're validating the data set, how good the data set is, and are you getting the exact required R-square values or not, right? If a model, if the data set that you have taken, which is having specific R-square values, use that data set for creating the model so that it can be used for virtual screening kind of thing, right? So you can see the training database is there, that is obtained from Campbell, right? Then you prepare the database, removing duplicates, removing the salts, right? All those things is carried out by this software itself. Then featureizations, you calculate the fingerprints, then classify them based upon the RMD algorithm, that is random matrix discriminant algorithm, and then gives you the output about R square and Q square values. All the general AUC, all those things will come up here, right? And the same model can be used for screening of a database also to give you a hit molecules, right? One molecule or 10 molecules kind of thing that can be obtained from this particular, right? So how to use it kind of thing, right? Now usage is simple. If you have installed your Miniconda already, how many of you have Miniconda with you already installed? Right. So you can just go to the Miniconda terminal. Right. I'll just open it. Right. You have this prompt, right? Fine. Here you have to install, get the environment set for this PYRMD. Right. So already that PYRMD zip file is shared with you all people. You have downloaded it, extracted it, right? Fine. So first thing is we have to install it as well as install the libraries of it, right? I don't know if it work for you people or not. These are the codes to start with, right? Conda update Conda, you can run it if it not updated, right? Otherwise you can leave it. You can just try to go to the next step, right? So just take this Conda, create. Right, let me share this file into the WhatsApp group so that you can use it, right? You can use it anytime you want. All the commands I have shared in the WhatsApp group, right? So you can run them. That will activate the PYRMD environment kind of thing. But when you're running it, first you see that you run the Conda update Conda. If you have to update your Miniconda environment, then go to Conda create -n PYRMD Python equal to 3.10. Right? Is it running? I'm not doing it because my environment is already created kind of thing, right? If your internet is connected, it will be happening in 5 minutes kind of time, right? The first command, Conda update Conda. I've shared the commands in the WhatsApp group. It's running? Done? Then the next conda create minus n pyrmd python is equal to 3.10. Please run that command also. If you want here, there's no need of Jupyter to be installed because already been installed for you, I guess, if you have run it, right? So whichever is required, you can keep, others you can delete and use it, right? Like scikit-learn. For update command, you are saying? Okay, it gave an error. Okay, anyone else? Is the same error coming? Huh? It proceeded? Yeah, why? Just why? Just type by and press enter. It will go on. If those two commands are run for you, right? The next command I'll also show you. Once the two commands are run, and if you type that conda activate pyrmd, you'll see the base will change as pyrmd. Base, instead of base you are seeing pyrmd, right? That means your environment is set, right? Now you downloaded the zip file of pyrmd, okay? Go to that, like I have, right? So I have position. So you have to extract, wherever you have extracted, you have to navigate to that particular folder, right? So here I have placed it in my D drive, right? I can show you. In my D drive, I have this JP folder. In this, my pyrmd is there, and it has installed this. Once you extract the zip file, wherever you extract, you have these files. That's all. My path has changed, so I have come to the placed. Okay. So everyone is done with there. Just change the direction, right? Fine, right? So you can just go to the directory, right, and then run the next commands. That is to these commands, right? Conda install C, conda force, scikit-learn, all the required libraries. If not, at least the last one should be done compulsorily. Conda install minus C, conda forge, stats models, rdkit, and openbabel. So these are the libraries that is required for running this pyrmd. So you have to install this in the, means these libraries should be copied into this environment. This command is doing that only. It is getting these libraries into the environment of pyrmd. Right, step by step, run these commands. That's the only thing you have to do. Right, it will be creating into the pyrmd file. Once it is ready, one time these commands are done, next time onwards you can just directly open Anaconda, go to activate conda, activate pyrmd. That's all. That is sufficient. Right? No need of every time doing it. Once everything, this installation is done, for next time onwards you just go to conda, activate pyrmd. It will open up. Just change directory to the place where you have put your pyrmd main file. Just change directory to that, right? Once that is done, right, this is my file, right? Now if you open the directory that you have extracted, right? Are you seeing these files? The directory where you have extracted pyrmd, right? Are you seeing these files there? The pyrmd zip file that is shared in WhatsApp group, you have downloaded it, you have extracted it. Open that extracted file and see these directories. You can change that. Got the base? Yeah, change directory to the file where that has been extracted. That's all. Yeah. Yeah, that's it. Got it. Right? Now you are seeing these files, right? What are the files there we have? Yeah, tutorials is there, benchmark. Okay, you might not see because I have run few of them. You are seeing all these things, but you might have tutorials, right? Configuration file, license, pyrmd environmental.yml, right? And pyrmd v version 1.03. This is the actual Python script that runs, and you have to configure these files, right? Now you open these tutorials. Open the tutorial. You've got two folders, benchmark and screening, right? So in this you have this configuration underscore benchmark configuration file, right? Now open that in a notepad. Right click, open with notepad. Open that file with notepad, right? You have opened it? Right. Now it says the, let me come to the top of it, right? Right? It says which mode I want to run this automated tool, right? So there are two modes, either benchmark, right? It is mode is equal to benchmark. If it is screening mode, it will say mode is equal to screening. Right? Two modes only, benchmark and screening, right? Next you have got indicate the database file to screen for screening mode, otherwise leave the entry blank. Now I am doing it in benchmark, right? So it's not a screening database, screening mode I am using, so it is kept blank. If you are doing screening, you will have a file name there, right? Then screening output file name is given, right? You can change these names accordingly, your requirements, but don't change these particular parts, right? If you want to change only these names, you have to change, right? Be careful while changing the configuration files. Then it says if the molecule has to be converted into an SDF file format, it says false. You can keep it true, it will generate that, right? Then right, indicative screening mode, the active compound should also be converted, right? It's kept false. Then benchmark mode indicate file where to output the benchmark results, where to get the results. I'm giving the file name there. You can change the file name, but keep the standard ones, right? Then it is asking for the training data set. Indicate if one or more Campbell database will be used as training set, true or false. If you are using the database that you have downloaded from Campbell directly, okay, just keep it as true. If you are not having the database from the Campbell one, you are using your own database, then you make it false, right? Fine. Now here what we have said is benchmark results or CSV, okay, right, it is kept as true. So in this, in your folders, do you see this met underscore campbell.csv? In your folder, you have this, just double click it, open it and see what it is. Don't do any saving, don't do any editing, just open it and see. Right, you have these molecules there, right? All the molecules you have there, how many? Around 8,000 are there. Yeah, 8,985 molecules are there, right? And you can see they have all the Campbell identifiers are there, right? Campbell ID, Campbell name, smiles is there somewhere in between. Smile notation will also be there, right? It's in a CSV format, so you're not segregating it, but you have the smiles, you have the A-log P values, you've got molecular weight, many of them. Standard values are there, right? Standards are there, right? So you will have KI value, IC50 values, right? Or you can have EC50 values in the standard values there. It will have the standard units also, micromolar, nanomolar, whatever it is. And you have the activity values also given in that. Some molecules might not have activity values. Some might have that greater than symbol or less than symbol, right? All those things are there, right? If you download any exact, I'll just convert it and show you, but I don't want to save it. Right? The data actually is like this, right? You got a molecule, right? You have molecular weights. What is the assay for that, right? This is directly downloaded data from Campbell database, and if you see around here, the standard type, its inhibition percentage, IC50, or it can be, see it is here, you see it is Ki, it is Kd, right? Different inhibition, what type of experiment they have done that? Relation, is it equal to, is it greater than or less than, or there is no value at all here, right? Actual values here, right? And standard values, right? So this is how the Excel CSV file looks like. Don't do any editing, anything, just use the CSV as such. Now, if you have to run for your files, what you will do? Download from the Campbell, keep it here. Just keep the file here. Download the Excel, paste it here. Right? No change. As it is, you keep. And change the, here, this file you are seeing, right? It will ask me, where is the database? And I have to give the file name here. Right? Here normally in your file it is written as met_campbell.csv. It is written as met_campbell.csv, right? That file name you have to change with the file name that you have downloaded. That's all. Just change the file name there. Download the CSV, change the file name there. That's all. Keep the CSV in that benchmark folder, change this file name here, right? Then you have got next algorithm, right? If it is not a Campbell database, then you have to go for all these things, right? Mention, create an CSV file for actives, create a CSV file for inactives, give those file names here, right? Which we rarely do because we don't have that much database, right? We always depend on Campbell or drug bank or somewhere from. We get the data from those places only, right? Right. So we use, but if in-house you have thousands of molecules with activity values, then you go for this, the second part, right, which is non-Campbell database ones, right? Right. Then it comes to fingerprints, right? What are the types of fingerprints it can? So it requires a RDKit type, right? So these are all we have installed, right? So you can change based upon the requirement, right? Faster one it is ECF. There is an RDKit can also be used. Standard what they are using nowadays is RDKit ones, right? And here it is taken as MHF here, default that is taken, right? Some defaults are. Now how many bits of fingerprints that you want to run with, right? Standard take default value is 2048. It can be 1024 or it can be 1496 also. So that bits you can change as per your requirement. The more you keep, more time consumption it is, right? So you change accordingly, right? Then, yeah, this is true if you have to include hydrogens also, right, for calculations kind of thing, right? How many iterations you are running, you can change it, right? 5 kind of thing. If you want to introduce chirality parameters also, make it as true. It is by default it is written as false, right? But if you want to include the chirality like RS configuration, right, EZ, then you put up it as true, right? Decoys, that database is there. You can get decoys from there, but no, we are keeping it. Yeah, here it is kept as true. For this, already one set of decoy file is already given to you in that folder. Met underscore decoys is there. If you want to change it, you can get the decoys later from your side also. Add it to this, right? What this file consists of? It's just smile notations there. You can just open with Notepad and see. Just smile notations. Giving the molecule names. These are all the molecules from the DUT database, right? For decoys. You can add your own decoy molecules into this. Right. Right. So the important point comes up here is the activity threshold. How to classify here the activity and the inactivity threshold that you have to give. Normally it depends upon the database that you have taken, what is the highest activity value and what is the lowest activity value, right? So how you want to segregate it, right? Default they have given it as 1001 and 3999. It can change according to your database, right? If like it is a 10,000 Ki nanometer is the nanomolar is the inhibition constant, right? Very large Ki value, right? Or 0.01. So based upon that you change it, right? These parameters can be changed by you based upon your databases, right? Here it is given, they have given it this, right? And then you split the sets, right? Split for training tests, right? It just calculates kind of thing, right? Then how many times you want to repeat that experiment kind of thing, right? Training parameters are there, right? Now by default here active values is 0.95, cutoff values that is taken, inactive is as 0.95, right? The threshold they want to take it, you can change, it has given 0 to 1 you can change. Don't go below 0.5, right? Be there between 5 to 0.95 kind of thing, right? Better thing is go for the default kind of thing, right? Right. Now filter kind of thing, it is when you come for screening kind of thing, then you can put up this filters, right? Based on molecular weight, you can go for Lipinski rule of 5 or Lipinski, whatever factors you want to put in, you can put in. And so once you have done the required changes, major thing what you have to change is just get your database, give the database file name, right? Change the activity threshold. Just these 3 things you have to do. That is the best simple thing. Get the database, change the file name, right? Give the activity threshold. That's it. Just run that particular script here, right? So I'll just go to this CD to tutorials, CD to benchmark, right? How to run command? Simple. Python right, space, you save the configuration. Simple, what you have to do is you just save this file, save, right, and run this command here, that's all. This is the command running for it, that's all. You create the put the CSV file, change the parameters there, save it, save the configuration file, right, and run this command. If your installation everything is run and my file is right, it should start running. Right? Now it takes for few people it might take 20 minutes minimum run time. It might go for hours together based upon databases, right? Which one? So you have to, that conda forge didn't run properly. Right? Is it running for any one of you? Did you try? Okay, don't, because sometimes it might hang up because the data set there is a huge data set, right? So it might take time. But once, so I showed you in this there was 8,000 molecules. Once it runs up, it generates this clean training database, right? I didn't get you. You just type Python, give a space, right? Type capital P, small y, capital RMD. Just press tab, it will give you. Just press tab, it will give you. Right? Version 1.03, space, press C, type C and just press tab. It will give you the file name again. Just press enter for it. Right? See, if your libraries, everything installation is done properly, then it will run very fast, no problem. Now you see that 8,000 set is been converted to only 1717 set for me. Right? I had 8,000 molecules there, right? But here it is only 1717. Means it has removed the duplicates, it has removed the salts, right? All these things, the molecules without any values, everything it will clean up. Right? So there is no need for you to do the curation. The software will do the curation, give you the benchmark values. If the process is over completely, right, at the end, you will have these same statistical files that you have for the area under the curve and all those files. You will get it here with the AUC values kind of thing, right? And also the benchmark result. Now here, in this particular software, they're not talking about R square and Q square, right? They talk about TPR and FPR. What is TPR? True positive rate and false positive rate, right? So it's based upon that. Means true positive means which are actually active. False positive means which are not active but they are reported as actives. Means inactives been reported as actives. If the model is good enough, you should not get any FPRs. FPR should be 0. Right? False positive rate should be 0. Then it gives a good model kind of thing. Right? TPR should be high, that's fine, but FPR, make sure it is 0 kind of thing. Right? Even if we have true negatives, no problem. False negatives also, no problem, but we should not have false positives, because we take that false positives, we go to synthesis, we go to activity, it's a failure there, right? So better not to have any false positives, right? Right. So you can see all the statistical values and kind of thing, right? Everything here, what is the precision, what is the true positive rates, right? So you can see false positive rates 0.0007. If you convert it, it's less than 1, right? So that's how we take it up, right? So this is to train the model kind of thing. Then you can use the same for screening kind of thing, right? So you go to screening, you have got the screening configuration file there. Just open with Notepad. You can see here the mode they have changed. Mode is screening now, right? The sample database that you want to screen, right? That has to be given in simple smile notations only, right? So I'll just show you how that looks like. So this is the sample database that we have, right? I'll just open it and just see. Only smile notations with the molecule name, right? So you have to get this database, right? Which are like, if you are trying to, for your own set of molecules, 100 some molecules, just take the smile notations, give the molecule name there. That's all. Paste the smile notation, give the molecule. Paste the smile notation, give the molecule name, save it as .smi file from the notepad also. That's simple thing that you can do. Nothing else is required there, right? So this file has been, here I have this. I've just written my mql underscore sample.smi. This is my database which I want to screen, right? The results, all rest all is same kind of thing, right? You can see the database which is used to model it, right? We'll use this database, right? Metchem underscore, same. For screening also, you need to have a database already with molecules kind of thing, right? Then you should go for screening kind of thing, right? So why benchmark has to be done? I can correctly come to this, right? Isn't it? Because it will run the model with this database, metcampbell.csv, right? Generate the models and it will apply it onto the screening database and get me the molecule out. But why to run benchmark? To see if the database that I have taken from Campbell, is it good enough for me to use it for screening or not? Right? I can directly go here to screening, no problem. But is that model that I have used there is good enough or not? Right? If with what if false positive rate is very high, right? I have wasted my time on screening it the other molecules based upon this model. Right? So first run the benchmark, see if the model is database is good enough or not, then use it for screening kind of. Right? Just change these values, just give the sample database there, right? Rest all is same. Instead of mode, benchmark, it is screening. Rest all you can just scroll down. Everything is almost same. No change at all. Have you seen that? Now this also I can run. The advantage with this is that I can run multiple at a time. I'll just open another Conda window. I'll just run the same command Python. That's it. It will start running. Just take the database, get the CSV file, change the file names. If your Conda environment is ready, your library is ready, you just put the database, screen it off, right? That's why it is automated tool that they have developed kind of thing. It's available in GitHub, you can download. The article is free to download, you can read it, right? So so once the screening is done, here also you can see the cleaning database is ready, right? Predicted activity is dot. So out of that 800 molecules that I have, from that it will give me the end, one molecule. It has given me only one, and this is the activity for that, the molecule. So this will be the output for you once you run so all the actives that has been screened from the database will come as a smile notation. These molecules you can use for your further structure-based analysis for docking kind of thing, right? So now because we have time, right? So we have time. So if you have in background it is running on, so I guess for others also it is running kind of thing. I'll just show you few things. I know many of you know it, but few of you not know where to use some of the docking based, web-based tools for docking studies kind of thing. This is MQL one-click docking, freely available ones kind of thing, right? This is the window here. You can just draw the molecule, get the smile notation from there, paste it here. That's it. I can get that one here and it's not reflecting. It's not reflecting here, I don't know why. Screen reflect. Acha, wait. Because my presentation is on. Right, I understood. Right, so I've copied the smile that I obtained from here. I just paste it here, right? It gives me the molecule. Here I have to give the select target or upload a file, the PDB file that the protein on which you want to dock, right? You have to give that file here and the coordinates of the active site, XYZ coordinates of the active site. You just give it and just say dock, it will give you the docking results for that, right? Preferably give a PDB file which is processed by you already, right? With which you have added the hydrogens, included the salt bridges and all those things, right? So this is one simple one, right? Web-based one. The other one, yeah, this is also a web-based one, but the advantage of this is called as MolModa 1.01, right? Okay, what I'll do is, I know people don't know which are these ones. I'll paste them in the group so that you can use them, right? The problem with the web-based one is you have to submit it. It will take their servers, run it, and give you the result later, right? Now to overcome that, you can use this Molda, right? Where it is a web-based one, but it uses your system CPUs for running the docking process. Docking process everywhere, it's the same thing. You require just 3 things. What are they? What are the 3 things you require for docking? One is the ligands for docking. Second one is the protein for docking. Third one is the coordinates, the active site. It's a basic thing. It's a physics-based principle. You need these 3 things, right? If you don't have the coordinates, you can go for a blind docking also. So in this, blind docking is also available, right? Molda, you can go for a blind docking. You can also identify potential cavities also, right? Where the cavities are there, those potential cavities also you can identify and you can use it for docking there, that particular molecule, right? So you can just go through there. You have to just first thing is it's like a web-based platform only, but you need to create projects, right? So I'll say file, new project. In the project, everything is saved kind of thing. Anyone who has used Schrodinger, right? It's almost similar like that, right? Its only thing is web-based, right? You create a project, get the files there, docking studies and all those things, everything can be done. But you don't need Schrodinger, you don't need that license. It's free. It's totally free. And you can run not just one molecules, n number of molecules you can run it in that. No, you can use this, right? If you have a better server kind of thing where you can use this web platform, put it, you can do the docking studies, right? So this is another one. The other one is, okay, this all of you know, that is ThorDoc. Probably many of you know this. This is another virtual screening. Free, but it's a server based. You have to submit it. They'll process and give the results after 1 or 2 or 3 days, depending upon their server availability, right? So this you can use for structure based virtual screening also, right? So these are the online modules you can use, right? That is click docking, MolModa, and ThorDoc, with what we call it as. And there's another thing which is like your PYRMD, that is Pignet 2. It's a bit complicated to run. It requires many libraries. Almost 4.2 GB of libraries is there for it, right? So that's why I'm not going into that, because we can never download it here. and the docking process takes also time. This is again AI based one, right? And it's Miniconda based. You have to have Miniconda, right, that you have installed. You can download the files for this from GitHub, right? Go through their README file, do the installation, what are the libraries are required, what are the backend sources are required. That sources is of, I'll show you. The sources what they have given is, this is the sources, which you can find it in Zendo database, right? You can see the total size, it's like 1.3 GB, and it's almost 1 GB here. Total source files is around 4.2 GB, right? So you have to download it, keep it in those dataset files, use it, just follow the command, like same, like your PYRMD, you have got configuration file, in that also you'll have a configuration file, change the file names, run it. But only thing is, you have to create an environment like PYRMD, like we have created a conda and create PYRMD, like that you have to create for Pignet, right? Then install all these libraries in it, right? Conda, install C, Forge, Conda, Forge, all the libraries you have to install it, right? Then go to this Conda, activate Pignet, go there, change to this directory, run it. The running process is almost same, like your PYRMD, but only thing is you require more library files, a kind of thing here, right? So this is structure-based virtual screenings. You can do it here, right? This is offline version, right? Pignet 2, but you need to have Miniconda and all those things. Online version, you can go for Thordoc, which gives you the results, right? Molda you can use if you have a better CPU space kind of thing, so that you can use it online kind of thing, but it's easier kind of thing, right? Right. So once we have a molecule from virtual screening, right? Let it for ligand, then what I suggest is always start with ligand-based virtual screening, come to structure-based, right? And then go to these things. But there are some cases where we don't have the structure, right? Then only ligand-based is the only opportunity. In some cases, we don't have database of molecules. Okay, if we have database molecules in Campbell, we do it, we use it. But what if we don't have? Then you have to go for structure based. So it's all about the availability of information, right? You have information, you can use it, you can process it, you can modify it, get the results out of it, right? So the one thing what is required for these things is Python programming, this that ChatGPT will help you on that. That's not a problem, right? But more important thing is the chemical intelligence, right? Artificial intelligence is there, fine. You need to have the chemical intelligence, you need to have the biological intelligence also, right? So how to use, which molecule to use, which protein to use, all these things is basics that you need to know before starting into these things, right? So, okay, we are using artificial intelligence, but to use it, we should have the CI and BI also, right? So, right. So, once we get the molecules, the other thing is, are the molecules safe or not? Right? That is ADMET. This is one of those tools that can be used. It's a web-based one. It has its offline version also. Same Miniconda, download, create the environment, use it. Right? Yeah, you can use. There are many. I'm just showing this. One is there, and another one is DPK. PKCSM, right? PKCSM was, I'll show if I have that. PKCSM, did I? Which one? Yeah, that's a problem. So offline version, if you go with here also ADMET, it will take 1,000 molecules. Input up to 1,000 molecules, right? So ADMET we use only after screening. We don't have 1,000 molecules to be put, right? Hardly 10, 15, or 20 molecules. Toxicity prediction analysis for how many molecules you want to run? For the Campbell database directly, you want to run it. Okay. Yeah, you can run it. That's why I said this ADMET AI, right? If you download its GitHub version, I guess we have the GitHub version of this also. Yeah, you have this link. See. This is the GitHub link for it. You can download it. You can see all things are same file, same things that you have. Right? You can just download. 5 minutes. Yeah. Just go to code and say download zip file. The whole ADME software will be downloaded. Right? The only thing is you have to again go to that mini conda installation and all those things. You have to run it. All the scripts will be available here. You have to just modify the scripts, use them. That's it. But only thing is you need to have all those dependencies like OpenBabel, RDKit, scikit libraries. Everything has to be required, right? That's the important thing, right? Now here, if I go back here, let me close this now. I didn't get you. Yeah, there are few of the parameters. They are predicting. It's actually a graph-based theory. Initially, that they started is based upon graph-based theory, right? They have used. If you go back to PKCSM development kind of thing, they have used data set of molecules. They have actual toxicity values for those things. They created a model. Okay. Yeah, they have created a model for it, and that model they have put it here. And when you give the molecule, it goes to the model and give you the toxic value. That same thing they have converted. Improvise the model by applying the deep learning approach. Yeah, that's all. They don't give a value. That's what I said. That we need to have that CI and BI for ourselves, right? So you have to see. So that's why we don't go for a large database kind of thing. We use 10 or 15 molecules. If it says, then if we say it says what is the group of molecule substitution there which you have that causing that particular problem, you have to see, right? So just depending upon tools is okay, but you need to have your own judgment, right? You cannot totally depend upon you. That's that you should have your own judgment, right? I don't totally depend upon system or computers, right? I'll say just 60 to 70%. Rest all you should have your own chemical intelligence, biology, what all the concepts you should have, right? Sometimes it might give you a wrong result. You should be ready to analyze that result and see what is there, right? Now, how to operate this one? You can just down. You can just put the smile notations here, copy paste, or create a CSV file like I have shown it previously. Upload that CSV file. It will just run and give you the results in CSV format only. Both in PKCSM, in AI, ADMET AI, it's the same thing. You have another one that is Swiss PDB that also gives you a prediction, right? The Swiss portal is there, right? Initially they started with Swiss PDB viewer. It was only for PDB viewing. Like when I started way back in 2005 and 6, right? We had that simple tools free, which is Swiss PDB viewer to view PDB structures. And we started with that. Right now they have gone for all AI-based tools kind of thing, right? So all those things you can use. Right. So any other query? Ligand? Yeah. You can put the, see, that was a small database. When we have the threshold values, right? You change them, it comes out different. It's you have to play around, right? You have to just play around what kind of output you want. Based upon you change it, you get the outputs. You want one molecule, you want 10 molecules, it's about you, all right? You have larger database, I'll say only 1% I need, right? If 100 molecules, I said 1%, it will come one molecule for me, right? MD simulations, web servers, even I am looking for. MD simulations are a bit difficult. There are few, but they are like one server is there, but not working now. It's difficult. MD simulations, as you need a larger, what you call, the resources what you need is more. And we don't have that kind of support from any of the servers that we have, right? Anyone else? Right. Thank you all. I hope I have given at least some information to you, right?